Hello to my viewers. There's a question I want to answer this afternoon. It's a question from chemistry students who sit for IGCSE chemistry, GCSE chemistry, even WAEC and JAMB. They will be required to answer questions like this. And look at the question. Why do halogens get less reactive the further down the group you go? We're looking at halogens. Okay, the first thing you need to know is what halogens are. For students who are just coming into key stage 4, or for those ones who are preparing to come into key stage 4 and you're doing chemistry, halogens are the elements that can be found in group 7 of the periodic table. That's the first thing you need to know about halogens, that they can be found in group 7 of the periodic table. That means they are the group 7 elements. 1. The second thing I'd like you to know first about halogens is that halogens are salt formers. Halogens undergo different kinds of reaction to form salts. Halogens will react with metals, they'll form metal salts. Halogens will react with metal oxide. Halogens will react with metal hydroxide, and halogens will react with metal carbonate. But that's not what we're here to do, discussing the reactions with halogens and other elements and compounds. We're here to find out why halogens get less reactive the further down the group. However, it is important you know what halogens are, that these elements that we call halogens are found in group 7 of the periodic table and that they are salt formers. All right, so when we say halogens are in group 7 or they are the group 7 element, what that simply means is that the elements under that group have something in common. And what they all have in common is valency. All right, so the word valency, V-A-L-E-N-C-Y, valency, if you can see it here, that's what I'm talking about. When we talk about valency, we're just talking about the number of electrons that the atoms these halogens are made of have in their outer shell. So the outer shell, or the outermost shell, is called the valence shell. Electrons found in that outermost shell, we call the electrons the valence electrons. So this will mean that halogens having a valency of 7 is that they have 7 electrons in their outermost shell. All the halogens, that's what they have in common. They do not even need to belong to the same period to share the same number of valency. So I'm just trying to help us build a background before we delve or dive into answering this question. So we have identified that halogens are group 7 elements. We have also said that halogens belonging to group 7 means that they have a valency of 7. That means they have 7 electrons in their outermost shell, or they have 7 valence electrons in their valence shell. All right, so if that is noted, I also like to show you the halogens that we have. These are the halogens. The first is fluorine. This has been ordered in their increasing order of reactivity. So we have fluorine, we have chlorine, we have bromine, iodine, and astatine. These are the halogens. Though there is one more, the 6th one, but we're not talking about that one right now, but that one is radioactive. When we get to nuclear chemistry, we'll look at that. So we're going to take note of fluorine, of these halogens. And mind you, you need to notice the arrangement. If you check your periodic table, for those of us using New School Chemistry, Ababio Comprehensive Chemistry, whatever chemistry text you're using, check the periodic table, go to group 7, you're going to see the halogens arranged this way. Then you also notice that these halogens, they come with their chemical symbols or their chemical formula. What you can see here for fluorine, you can see F and a subscript 2. For chlorine, you can see Cl and a subscript 2, and bromine, iodine, astatine. They all have subscript 222 to tell you that these halogens are diatomic and they are molecular. But these are not the chemical symbols, mind you, they are the chemical formula. So this is the formula, chemical formula for fluorine. But the chemical symbol for fluorine is just capital F. It's chemical symbol. Chemical formula F subscript 2. Chemical symbol for chlorine is Cl. Chemical formula is Cl2. When you get to molecular substances and how molecules are formed, this will be, you're going to shed more light on this. All right, so we have said this about halogens. Now let's come to the big question. Why do halogens get less reactive the further down the group you go? Let's pick these two halogens. I'm going to use fluorine and chlorine to explain this concept. And mind you, fluorine here, the atomic number of this element fluorine is 9. And this is how we arrange it. This is the shell arrangement, 2 and 7. Chlorine, the atomic number is 17. And the shell arrangement is 2, 8, 7. What is common to both fluorine and chlorine is the last number, 7, 7. So I'm going to use a shell diagram to arrange this, the electrons found in fluorine atom and the electrons found in chlorine atom, because I want to use the shell diagram to explain why halogens get less reactive the further down the group you go. So you just have to be very patient with yourself and me here. All right, so let's look at, this is my nucleus, and let me take this as my first shell, and I'll take this. For my first shell, I have a maximum of 2 electrons that can fit. I'm going with fluorine. Then my second shell, 8 is the maximum here, but I have 7. So 7 will work here. The electrons are arranged in pairs. This is 2. This is 4. This is 6. And this is 7. So this is showing the valency of 7. This is chlorine. This is fluorine, and I have 2 and 7 here. This is the arrangement for fluorine. Then I'm going to go with the next one. This is the nucleus, and this is the first shell. I have a maximum of 2 electrons here. Okay. Then okay, we're going to keep this here. All right, this is the first shell. This is the second shell. Of course, 8 here. This is the shell arrangement, 8. This can also be a topic moving forward, so that you learn how we arrange this. This is the Niels Bohr's model. This is 2, 4, 6, 8, and this is the third shell, 7. So coming in pairs, 2, 4, 6, and 7. So this is chlorine, and this is 2, 8, and 7. All right. So I said I'm going to use the shell diagram. For you can meet me. Come to the comment section if you don't understand this. Once I know that a lot of persons who will watch this don't understand, I could take this shell diagram as a topic on its own. But if I don't get that, I'll just assume that we get it. So let's flow. Now, this is chlorine, and this is fluorine. If you notice, we have 2 shells here. That is this first energy level, second energy level for fluorine. But for chlorine, we have 1, 2, 1, 2, 3. This is the outermost shell. This is what we call the valence shell. For this element, fluorine, the outermost shell, which is the valence shell, the electrons in this valence shell are closer to the nucleus than the electrons in the valence shell of chlorine. And the principle or the chemistry behind this is that the further the electrons are away from the nucleus, the harder it is for the atom to gain electrons. And when atoms find it very difficult to gain electrons because their electrons, the shell is far away from the nucleus, it becomes very difficult for them to be very reactive. So the point is, the further away electrons are from the nucleus by virtue of the shell, the harder it is for them to gain electrons. And the harder an atom finds to gain electrons, the less reactive. So because fluorine is closer, the valence shell electrons is closer to the nucleus than that of chlorine. Fluorine will find it very easy to gain electrons, and because it is easy for fluorine to gain electrons, they tend to be more reactive than chlorine. So by virtue of this, it goes without saying that the most reactive halogen is fluorine, followed by chlorine, bromine, iodine, and astatine. As you go down the group, the atoms get heavier and they occupy higher energy levels that are further away from the nucleus. And because they are very far away from the nucleus, they will be less strongly attracted to the nucleus, and their electrons will not be very easy to gain. So on this premise, we're saying that halogens decreases in reactivity the further down the group you go, because the further down the group you go, the heavier the atoms. And the heavier the atoms, the further the valence electron is from the nucleus. The further the electrons is from the nucleus, the difficult they are to gain more electrons, to gain the noble gas electronic structure. So on this premise, we can say that fluorine, like I said, is more reactive than this, and chlorine more reactive than bromine more reactive than iodine, and iodine more reactive than astatine. What are you going to take note of? Take note of this arrangement, take note of the chemical formula and the chemical symbol of this element. Until I meet you again, go and practice these things and know why halogens get less reactive the further down the group you go. Bye for now.